Hello there, I'm Professor George Dickson and I'm a scientist working at the University of London in the UK. And I've dedicated most of my professional life to understanding and treating neuromuscular diseases like Duchenne muscular dystrophy. And actually it's quite wonderful and inspiring to see the amazing progress that has been made over time. And my lab was involved, for example, in the discovery of exon skipping, which is now being tested and applied by Sarepta to treat Duchenne muscular dystrophy boys. In addition, along with colleagues like Professors Chamberlain and Zhao in the US and Professor Takeda in Japan, my lab has contributed to the development of so-called microdystrophin gene therapies using adeno-associated virus vectors. Now, my lab has designed, for example, a key microdystrophin gene variant with almost 50-fold increase in activity, quite amazing actually. And we've shown that this gene therapy can be delivered through the bloodstream and is very effective in animal model studies, even more amazing. Now, with colleagues in the UK and in France and in collaboration with the biotech Genethon, we were very excited that our DMD gene therapy will go into clinical trials next year, hopefully with safe low doses and improved effectiveness. But as you know, several DMD gene therapy trials are already underway in the US using different genes and different viral vectors, and some very encouraging early reports have come out. So the whole DMD community, I think, is excited about gene therapy, that it may work well, it may produce profound improvements in this awful disease. However, it's worth pointing out from time to time that DMD gene therapy is not a complete bed of roses. There are some clouds looming on the horizon. For example, it's likely that the DMD gene therapy effects may wear off over time. We don't really know, perhaps over several years, and have to be repeated. But the problem here is that the first course of gene therapy activates the immune system in the patients and prevents successful repeated gene therapy. So is there a solution? Well, we hope so. With funding from Jesse's Journey, we've initiated a forward-looking project to try and solve this problem. We'll use a biological phenomenon called immunotherapy or immunotolerization. And the aim here is to enable repeat gene therapies. Now, our immune systems are actually naturally tolerant to a whole range of antigens, self-antigens, antigens in our food, antigens in the environment. And we will try to harness this effect to tolerize patients to the AAV microdystrophin gene therapy medicines. And hopefully this will allow one or ideally many repeat administrations throughout the lifetime of the patients, and in this way greatly extend and enhance the beneficial effects. Now, for me, this aim of enabling repetitive gene therapy administration is one of the most important to be tackled and solved in the next wave of advances in gene therapy research, which are coming down the track. Now, if our work funded by Jesse's Journey, supported by Jesse's Journey, yields a pathway to prolonging the gene therapy effects and to hopefully lifelong improvements in DMD patients, that would be, I think you would agree, a wonderful and important achievement. So we're working hard on that, and we'd like to thank you for your support of our research. Thank you, and goodbye.